All right, good afternoon, everyone. If you're in South Africa, or at least my time zone, if you're not, it's good morning. If you're in the UK, and to everyone else, just welcome for joining us. Today, it's all about data science, but it's from a different perspective. Rather than chatting to thought leaders who are working within large corporates, we've got Andrew Jones, who certainly has that experience training data scientists, running his micro enterprise as a solopreneur, training thousands of people to go into the data science profession, watching how the technology is changing, large language models and that's coming in, and then having to continually update and adapt his training model so that people are going in with relevant skills into big business and industry. I'd like to welcome Andrew and say thank you very much for joining me.
My pleasure, Colin. Great to be here. Thanks for having me.
So everyone joining, please do participate. Ask questions. I've got a lot of questions and I'm very happy to ask all the way through this 45-minute session, but it would be much better if we get your input and thoughts as well. If you don't have questions, you've just got ideas, you want to go and clarify pieces, please put it in. And if we can't get to it, then I'll try my best afterwards to make sure that we have a follow-up and send anything through that we think is going to be helpful and useful. So with that, Andrew, do you want to just expand on that and tell me a little bit more about your experiences before you set up Data Science Infinity?
So I have been doing Data Science Infinity for about 4 years. Prior to that, I'd worked in analytics and data science for around 14, 15 years. I started back in New Zealand, where I'm from originally. I didn't study anything to do with data science, computer science, mathematics. I stumbled into the field through a contact in a sports team. Graduating from university, I'd studied marketing and psychology. I was talking to the head of a marketing analytics team. I'd been talking to him and saying, well, I like math. I've studied marketing. He said, do you want to apply for a marketing analyst role? And I landed the role. And this is like, I didn't know you could code for a job. I knew people probably coded up websites. I didn't know any of this analytical data science type stuff was around. I started using SQL and SAS, which many of you might know, and just fell in love with it, how you could manipulate data, find insights, and then discovering machine learning, seeing something like a churn model for a telecommunications company was my first foray into machine learning, and seeing you could predict who was highly likely to leave the company in the next month. And then when the next month came, seeing that a lot of those came true, just something about this clicked with me. And so while I don't have the formal background, I've been passionate and curious about it and have continued learning and building. Moved over to London and have had a variety of jobs for consultancies through to working for a couple of years at Amazon, specifically within the Prime Video space. And then I spent around about 3 years consulting at Sony PlayStation, which was probably my favorite job of all time. Prior to running my own company, that was building machine learning-based features for the PlayStation 5, which was about to come out. A lot of those have gone on to get patented by Sony. So that's something that I'm really proud of. But also the job itself, you've got a PlayStation at your desk, and you can make the excuse that we just need some more data to go and play some games on your computer. So yeah, a really cool job. And that sort of really propelled me a little bit further. There was a point where, because of some shifts in how consultancy and contracting worked in the UK 4 years ago, I took the opportunity to create my own training program, which is something I'd wanted to do for a very long time. I'm in a unique position in that I've interviewed and screened so many people, and that's a fundamental part of it.
Why did you want to do the training as a switch, though? Because building a training program is fundamentally different to practically doing data science in a large corporate to come up with these predictive models.
So I love the hands-on stuff, and I still get to do a lot of that with creating the curriculum and creating the content and the projects. But there was just this time where it felt like this is the time to jump and do my own thing. There was a few ideas of creating my own consultancy, but I had all of this code and logic that I'd been working on for so many years squirreled away. And I knew there's some really good stuff in there that I can teach others. I always enjoyed mentoring others. I'd been in this position at Amazon and Sony where I had interviewed and screened thousands of candidates. I'd seen so many come in unprepared for a role in data science, whether it was a boot camp, an online course, or a master's degree from some prestigious institution. They weren't coming in prepared to work in the real world. I thought there's a gap in the market. Data science exploded, and there were so many institutions and companies that thought we can make a quick buck by throwing together some middle of the road training program to give people a certification and promise them the world. And it didn't work like that. So I thought there's a gap in the market to create something really good. It was that experience interviewing and screening candidates, which is my point of difference. I can genuinely help people get ahead in the hiring process. That's the stumbling block for most people. Anybody can learn a bit of Python and SQL, but how do you get ahead of 100 people in an interview process to get into the role? If you pay £10,000 or dollars for a degree in data science, but you can't land a role, the ROI is zero. Whereas if you can spend, but then earn a $60,000 a year job, which next year you get promoted to 80 grand and then build up to senior level, principal level, and you end up on $200,000 a year, that's the ROI. So there was this huge gap in the market, and I just thought I'm going to go for it. And yeah, it's been a really fun, enjoyable, and rewarding experience.
You mentioned that you hadn't had formal training in data science. You kind of stumbled into it, fell in love with it, and then learnt it practically by working in corporates and building on your maths knowledge and experience. That resonates with me. I reflected on how little I was using from when I'd been at university. The theory of university, the structure of a lot of the courses, when you get into the real world, it's it's completely irrelevant, at least in some of the courses. And I found that my learning was really driven by real life experiences, especially where there were, it was critical path, big issues, tight deadlines, lots of pressure. It was the phenomenon. I'm a big believer in your best people are often the ones that are learning actually as they're doing. Do you think universities still have a role in breeding our next set of programmers and data scientists? A lot of the big companies share your opinion, your Microsofts and the Googles, and they're just really looking for people that are as showing what they've been worth. Maybe they're on GitHub, or maybe they've been doing large projects outside of university. They've got experience in small startups, and it's not the qualifications and titles they look for.
I do think they probably have a place, but they need to change how they operate. If you think about how fast-paced the world of data science or AI is at the moment, why would somebody spend 4 years doing a course that costs them $10,000, $50,000, whatever it may be, when at the end of it, they've learned things which are no longer relevant? Of course, there are some things which probably won't become irrelevant, things like SQL and Python. They're more or less here to stay. Certain mathematical concepts, they're not changing. But there are tools and technologies which startups or online courses can be much more agile with teaching, whereas universities and larger institutions will struggle to keep that pace up. The other thing they don't often offer is expert guidance through the hiring process. A lot of their experience isn't primarily in industries. How do you help somebody deal with the hiring process? It is a niche skill set, getting ahead of other people in that process. So if you can't help people do that, there's no ROI for people, and therefore you're going to struggle longer term. So I think that agility that smaller companies have, is smaller educational or ed tech companies have, is a huge advantage. Whether you have a certificate with your name on it versus showing a GitHub repo or a portfolio of projects which showcases what you can do and the value you can add when you get into the role. It also showcases how you communicate, your problem-solving system. These things mean on day one, you're not expected to know everything, but we can see how you can solve problems, so we can throw things at you. Whereas a piece of paper with your name on it only tells you so much. My university degree, I wouldn't think means much. I'm not saying that a master's in data science from an amazing institution isn't worth it, and that probably does hold some weight, but projects and GitHub, which is similar in essence, they just show people exactly what you can do. And I think that is becoming more and more the case. And that's what I'm hearing from recruiters and hiring managers as well.
So we titled this conversation "The Problem with Data Science," and it was based on my experience of working with data scientists and being involved with data throughout my career. There's always been huge promise in most companies. I'm deliberately wanting to steer away from the TikToks and Googles of the world, who are masters at using data science, but your average companies whose primary product or service is not focused around the technologies and the predictive models that you use in data science. And so for me, that's banking. I always found that the promise is there, the opportunity is there, and we were poor at delivering on it. And there's therefore some sort of problem with data science and converting it and monetizing it in the way that I always felt was potentially possible. Why do you think that is? Why is there a problem with data science?
The problem with data science, right? Are you ready for this, Colin? There isn't a problem with data science. It kind of depends how you look at it. Data science can be one of the most valuable areas of any business because we're using the information to drive decisions, to help us make the right decisions, to help us move faster. If we think about it in the right way, there's no problem at all. There is a problem, a perception misalignment with what people think data science can deliver. It's not data science itself. It's, oh, data science will figure that out for us and solve our problems. So data science exploded a decade or so ago, didn't it? The term data science. While there is this huge amount of value that can be driven from it, data science itself as a term became this, I guess, panacea for everything and anything within a business. So data science will solve any data problem we have. Now, data scientists, true data scientists, you're unable to spread your resources and your expertise successfully across everything because you don't have every possible data skill set there is. That misalignment has caused a lot of problems. A true data scientist couldn't do some heavy data engineering. So data science has failed. Well, not so much. This is why we've seen companies over the past few years splitting headcount into data science, data engineering, data governance, data management, and all of these other things. They've always existed, but data science came along and we all wanted to be a data scientist. Companies were hiring data scientists, and when they couldn't do some other thing that they weren't trained for, we said data science failed. So data science itself isn't a problem. It's the perception of data science. And there's also this quite a naive view of this kind of splitting, and it's saying, well, this is a really bad thing for data science. Data engineering's taking over. And in a lot of cases, I think people wanted it to be a bad thing for data science. It was kind of the popular kid at school when you see them trip over, so you laugh because you saw the popular kid do something silly. I think the reality is we've seen the industry mature over time. It's turned out to be the best thing that could have happened to data science as a field. The engineering foundations we've put in place over the past couple of years, a lot of companies have done this. They're the reason why we're now seeing a massive surge in more pure data science roles, and it makes sense. Data scientists now can focus on their core deliverables with the data they need. Companies feel empowered to hire for specific projects and outcomes because they can see what data science will do. This is what data engineering will do. This is what data governance will do. And once you get that value starting to flow, companies are going to take advantage. With the foundations set, data science has streamlined itself a little bit, but now it's in really good shape to go forward. This view that it's data science versus data engineering is such a bad view, and I don't know why so many people have this view. It's always going to be data science and data engineering. They're just two pieces of a puzzle which are going to add up to more than the sum of the parts. It's so important that we, as an industry, see that there is more than one piece to this puzzle. And I think as we mature, we've seen this more and more, and it's a good thing all around.
Do you think there's a structural problem in most companies in terms of where data scientists find themselves working? And I always get the feeling that they are often placed within the technology function, or it's believed that data scientists should report into the CTO. And they should be centralized in some way or another. We should have these geeks working together in quiet rooms with pizza boxes at crazy hours, just doing this complex mathematics to provide data, whether it be automated real-time actions or reports so that people can take better decisions. And meanwhile, the business is blithely going on, having no direct interaction, and therefore we're going down these separate paths. Do you see that as realistic in terms of where we see a lot of organizations going, and is that a problem?
So I think there were two parts to what you said there. The first is they report into a certain part of the business. I personally don't have an issue where data science reports into if it works. But the second part of what you said, data scientists sitting on their own with pizza boxes, that viewpoint doesn't work because the best data scientists working best for the business is where they're doing the clever things with the data, but are interacting with the people responsible for the impact those solutions have, whether that's the head of marketing or the head of product. There's no value in being an absolute math savant unless in some very niche roles at niche companies. Most companies need people to do simple but sensible things with the data and then get them implemented. Part of getting them implemented is making sure that the stakeholders like marketing or product or whoever else it is understand what you're doing, understand the impact it has on their customers, because they're the owner of those customers within the business. Therefore, they trust that they understand what's going to happen. Those things get implemented and can add value. I think that siloing of data science is a bad idea.
Mm. When the other thing that I'm actually more worried that there's data scientists listening. I don't mean to offend them at all, but let's use the stereotypes just because it sort of gets the conversation open. I also imagine and see data scientists quite often getting super excited about the problem that they're trying to solve. Two things happen. One is that they'll want to go and build it when perhaps there were other alternatives. And what they're building may not actually solve that particular problem because the theory and the practice, a simple example is, and this is a very real problem that I came across, data scientists looking at how to do stock inventory management for supermarkets to take cognizance of predicted weather patterns. We're going to see thunder and lightning in 2 hours. We need to move our bread from shop A to shop B because that's where the foot traffic's going to go to. Perfectly sensible idea, perfectly reasonable to develop an algorithm to predict and give decision making, completely irrelevant for the business because there's no way they can implement that for their stock inventory management and move product that quickly, so it's wasted time. The question is, how do you get that data science team to be thoughtful about the practical possibilities and not simply the theoretical ones?
It's a huge problem. I think as the field matures, we're seeing more talk of this. If I was to boil that down to one sentence, it would be, as a data scientist or thinking about how data scientists work in your business, always start with the business problem and then work back to the data science or the technical solution, not the other way around. Don't start with an algorithm or start with a technical solution and try and force that in. Because as data scientists, we love the tech, we love the algorithms. I've done this myself many times and been burned many times. Even at some of the top companies I've worked at, there's been a problem where I needed to predict something and I've gone way over the top, try to over-engineer some sort of machine learning based situation. After months of work, I honestly could have just used the median value. For the solution we needed, that would have been fine. Think about Google Maps and you go, how long does it take me to walk to the supermarket? Do I need the answer to be super machine learning driven to say it's going to take you 11 minutes and 14 seconds? Or do I need it to say most people get there between 11 and 13 minutes? That's a fine solution. I don't need to know to the second. So is there a simpler way that we can align with the business goal and deliver it faster and deliver it better? Yeah, I think we always need to start and think about what's the actual business problem and what are we trying to solve and what's realistic around what we're trying to do here. Because I've done it myself many, many times.
You teach that. How do corporations and organizations put structures in place to encourage their clever data scientists to think in those lines?
I think it does come down to how you're taught as a data scientist. It's a huge part of how I try and teach within Data Science Infinity. Everything we do in the course is not just here's how you'd code this and this is the output. It's very much like we do that stuff because you have to do it, but it's thinking at a hypothetical level, because these are hypothetical situations that we have in the projects. How would this be implemented? What are we trying to do? What other solutions could we consider? What do we need to say to the stakeholders? How would we explain it? And I even have sections in the course around how do you take a business problem and frame it as a data science or technical solution? Because I think if we can get the next generation of data scientists and data analysts coming in with that right mindset, that right balance between the technical and the commercial or business acumen, I think that's where we start delivering more and more value. Like I said before, there are companies and roles where it's at the cutting edge of the field where it's all about just being extremely good at math and really figuring out these nuanced problems. But for 99.9% of data scientists and analysts, it's that balance between the technical and the commercial.
When I look at the majority of businesses, I think there is this thin slither who are very used to using data scientists, but the majority are, I would say, data science light. If we move outside of these technical businesses, the TikToks and the Amazons of the world, and we think about perhaps manufacturing or insurance to a degree or 1,001 other things, they always seem a bit data science light, and there's opportunities to use data scientists. Now, a few years back, the argument would have been that they didn't really have great data sets and it was very expensive to get people and pay them because there was such a limited supply. Has that started to switch? Are you now seeing more types of organizations bring data scientists in? Are they getting value out of it?
I think there's more and more focus on data itself. From what I'm seeing, data science is finding its way into virtually every industry there is, not just tech industries. You think like healthcare or Retail's obviously been one where there's a lot of data science. If you look at any industry now, they're looking for data scientists because people are looking to collect data. A, it's very valuable because it helps you make the right decisions. It helps you build good products that can be useful. But there's this other where you've got investors for your business, or if you're on the stock market, the shareholders are putting pressure on the board, who's putting pressure on the CEO, who's putting pressure on the heads of departments. And one of those things is, hey, we need to be using data. We need to be using AI. Can you show us what we're doing with AI? So therefore, there's a lot of emphasis on that. And that's dangerous in one respect. It means that we get a lot more financial investment in data and in AI and machine learning within companies. But often that comes down to, hey, we just want to do whatever we can. We're going to sign up to this company just to tick the box and show the CEO that we're doing something with data. That's a dangerous position to be in. We've been there with data science and that matured. Then this generative AI came and now it's happening again. Like every company trying to embed some sort of Gen AI solution in, and they're trying to force it in. I think it's a two-pronged answer to your question. Yes, we're seeing data science and AI spread across the board. Yes, we are seeing value, but we still have a lot of cases where we're not being efficient with the spend to get that value because we're so excited and under pressure to showcase that we're doing something with AI. Even if it's not really what the customer wants, we have to be saying, we're doing this with AI. You see it everywhere, whether it's a washing machine or a hard drive for a computer, it's AI powered. That's come from market pressure and trickle down pressure within companies.
The two comments on the chat. I'm almost wondering whether one answers the other, but data scientists sitting with the business is about proximity. Without cross-disciplinary undergraduate degrees, how are you going to realize value from your data scientists? How are you going to get them to have this broader perspective?
I
They
don't
can go
think
on your
I don't
in
think
the real.
anybody needs any degrees, to be honest. I'm not saying a degree or a master's is a bad thing. It's a fantastic thing. But if you get some person straight out of high school, they've got no degree. But if you bring them in and you teach them Python and SQL and Tableau and machine learning, that's cool. But you should also be putting emphasis on teaching them about the business, information about the customers, showing them what is it that this solution will do for this customer. What's the impact on the business, on profits, on revenue, on costs, on customer acquisition, on customer churn. We need a balance between technical skills and commercial skills. And most of that comes internally. A lot of the time you will learn your technical skills externally. You can learn them internally, of course, but truly learning about the business and the application of those things and the impact they have on the key metrics that drive that business, right down to the most simple one, like how does this business make money? That really can only come internally. So if you can have some sort of emphasis on it at the very least, where you're truly trying to tie all of the technical things that you're doing to key business metrics, and that becomes the language of the business, you're going to get more and more value because people are going to start thinking about the technical solutions as answers to the commercial problems. I just think it's a cultural thing within companies that we need to be balancing out technical and commercial.
Culture piece is very interesting. I interviewed a chap called Roger Krobler who runs a successful investment fund here in South Africa called Ethos AI. Before that, he ran real insurance in Australia, and they were incredibly successful. They used machine learning, data science to drive massive efficiencies inside their business about claims and payments. They were able to reallocate most of the money they saved into huge marketing budgets, which gave them the advantage against their competitors, and they became pretty big. One of the items that he's always strongly highlighted is you've got to have a data-led decision-making culture if you're going to get the benefit of data. And you've just opened up that with this cultural thing. I see most organizations don't have that. What's your take on this idea of the culture has got to be driven by a data-led decision-making ethos?
So I think data-driven is always the best way, unless you need to be acting so fast that the data can't tell you the answer. From a culture of data-driven first, I think that that's only a good thing.
I'll just be honest, a lot of board and exco members I talk to are very much taking decisions based on gut, based on the proximity of people that they trust, conversations that they have. I've got this lieutenant who's worked with me. We've been with each other for years and years. Therefore, this is the decision we're going to go and take. I don't see data at the heart of decision making in many people, even in industries that it might surprise you.
So that's true. My experience from working at Amazon is extremely data driven. If you're proposing a solution, it has to be data driven. And if it's not, it will get pulled apart as well. How do you know this? How do you know that? You can't prove that in the best kind of way. I mean, I'm not saying people are mean to each other in the meetings, but there is a culture of you have to prove it with the data. And I think that's very good. There is still value in experienced people using their experience, because we can say data driven is like an oracle and data driven will tell us everything. If you give me a pharmaceutical drug and you say, tell me how effective this is, I can prove it's effective and I can prove it's not effective just as easily with the data. So data can be used in a whole lot of ways. There needs to be a culture where it's data driven, but done in a way where we're looking for truth, not where we're looking to use the data to support our gut instinct. When the data comes in and it doesn't, we sort of dispute it and say, oh, go look at that another way. I've interviewed, shockingly, a lot of people, often from pharmaceutical industries, and I've been talking to them about their analysis of things, and they have said, we did this analysis and it came back this way, and we had a problem where we had to redo the analysis to prove something else because I was trying to probe into exactly what they'd done. The idea that you could use data to support a hypothesis and then be told by the business that's not the right thing, can use the data to find another conclusion, that's not data driven. That's using data, but it's not truth driven. It should be truth driven by the data.
To the question from Deepak in a minute, but where do I start on this one? We've only got 15 or 20 minutes left. One of the other practical issues that I see in a lot of companies is they just don't have the data. The data is messy. And so they can't even start on this journey, and they end up in this vicious circle of they know that they need to be doing more analytics and data-led decision making. But the data quality they've got is just too poor. It's too disparate. It's spread out across multiple systems. And then they look at the cost of trying to bring that together, and it gets convoluted in the whole IT strategy. Are we going to move everything off-prem and put it on cloud? Do we need a big data lake? Where are we going to hire these data scientists? Oh, this is suddenly starting to look quite expensive, starting from everything in terms of the quality or lack of quality in people's CRM systems to the sales models, the stock inventory control management, and these massive ERP systems. They're sitting there with huge amounts of data. They try to get started and very quickly get frustrated because it's not standardized and it's basically unusable. To me, that seems like a major stopping point for most organizations to move forward. This is an insolvable challenge.
The best way to go about that is to sit down as a company, think about what are the things we're looking to achieve, how does data fit into that, and then build some sort of proof of concepts. We might have 20 different things we're looking to achieve. What's one of them that can be supported by the data? Let's get some sample data from our big, messy database. Let's take a sample of that, put it aside somewhere manageable and small, and let's clean that up and prove there's some value here. This MVP thing is an enormous part of why we see so many data science and AI projects fail is not because there was something wrong with the project, it's because we didn't start simple, we started super complicated. Pick the number one priority thing that you want to do as a business, isolate some data somewhere nice and easy, get it cleaned, get the people from the business who know what they're talking about with that data to get it in the best possible shape, get the metadata and the data dictionary sorted so we truly know what this data is, and then prove the value of that. If we did this with our full data set and this was going to get us more customer acquisitions or save people from churning, but prove it first. Don't shift everything over to the cloud and then go, oh, it's still garbage, even though it's somewhere else. Of course it is. Prove the value first with something simple. Get everybody on board, understanding what they need to do from data science to data engineering, leadership team, data governance. Get everybody on board at the simple level, and everybody can ride the elevator up from the simple MVP version or the proof of concept up to complexity, scaling it into something worthwhile. Start just isolating small bits, solving a true problem. When you see value and the costs are outweighed by the benefits, scale that up. I empathize with people who have terrible data lakes because it is a hard situation to be in.
What's your view on data classification and curation? Who does it? How do you do it? Can you automate it? I guess it's different from industry to industry. Great question.
It's super important. I don't think it matters too much who does it. Every business has different names for different people. You do sometimes have data quality teams, data assurance teams. You've got data governance. You've got like data engineering themselves often do a lot of, filtering and cleaning of data. So it doesn't matter who does it particularly, but it's super important.
It is super important, but like the hidden heroes, because they're not incentivized or paid in the way that your other guys might be. Data cleaning is so important. I want to use this data set so I can better understand my client target market, do predictive analytics. All of these are uplifting sales, allowing for cross sell, improving margin. They're all profit driving steps that you can take. I can't think of anything more important. I think
Mm.
that the guys involved in that should be getting paid significantly more than they do. And yet, I get the sense that because they're out of sight, out of mind, and only the real specialists really understand how technically difficult it is to do that sort of work, they're not getting the big bucks.
Yep, totally agree. It's the same in society, right? Shouldn't a police officer get paid more than anyone else? They deal with grisly things all day, every day, but they don't. Nurses or police officers, they don't, which is backward. But it is super important. They should get paid. I think in the past couple of years, we've seen the split off from data science into data engineering alongside data science. If you were to simplify that down, data engineering gets the data, the infrastructure, and the pipelines. Data science does their magic once the data is ready to go. And we've seen that explosion of data engineering. As soon as companies get those processes in place, they don't need a whole lot more data engineers. It's a maintenance thing, unless you're getting new and novel data all the time. Now, we're going to see another explosion of data science because companies are getting themselves in this position where their data is now good. So they've got these deliverables, they've got new possibilities of what can be done with that data. That's what I'm super hopeful about for the industry.
Dirk, are you there? Do you want to ask a question?
Yeah, how's it, Andrew? Good to chat again.
Yeah.
Quick question. In your experience, what works best, a centralized data team within organization or embedding data experts within business units?
It's a tricky question. I've heard it before, and I don't have a strong opinion on it. I think it can be done either way because I've worked for companies where you've been a data scientist on a specific project, and I've worked in data science teams where you're kind of, your resources is pushed around depending on where it's needed. And in both cases, I didn't necessarily see one as being better than the other for the business or for myself. There's been situations where as a data scientist myself, I've liked both. I can get a better understanding of the value I'm driving, whereas where you're spread around more, you end up doing the technical stuff, but you get less of an understanding on the true impact that it has because you're spread a bit more thinly. There is value in having data scientists assigned to certain areas because I think that we need to get this balance up of technical with the sort of business understanding, domain knowledge, whatever you want to call that side of it. So I guess if you're fully focused on you're a data scientist within the marketing team, you can really get to grips with how the solutions you're building are affecting the marketing KPIs. And that's a good thing.
Ariella,
Hi,
Hello.
can
going
you
to
hear me?
ask you.
Yes, I posted it. Very interesting, and thank you for sharing this very insightful session. We realize that this is a industry that's in dire need of training because we work with graduates that have a degree and diplomas in data science, but they're actually not able to work in businesses many times because they don't get practical experience. Many of them have been unemployed. As you're saying, you need to have the business acumen to understand how you interact with people. One of our purposes is to place these youth or direct them to positions. And we find that not many companies have positions available. Unlike the research out there shows that there is a skills gap, when you try to find companies to host graduates, it wasn't as much as we thought. Also, we realized there's a gap in knowledge of CEOs of how to utilize data science in their company, which I think that's one of the reasons you're probably running a session like this. I just wanted to find out your thoughts about that.
Yeah, I think at the graduate level, it's potentially become harder in the last year or so. And then you've got AI coming out, the generative AI stuff, which I think companies feel like, well, we can get AI to do the simple stuff. And there might be some truth to that in some companies. I don't think there is truth to that across the board. They need to be part of the process. They need to be a big part of the process. But maybe the lower end has become a bit trickier. If you are a graduate or working with graduates, trying to get them up a level with their training as soon as you can is a very good thing. If you can get them to the point where they can showcase projects that are upper level, that showcase value, that showcase communication skills, that showcase how you'd solve a problem, no matter what problem it is, like thinking about demonstrating, super simple example, I've got 3 possible algorithms or tools I could use to solve this problem. How do I weigh up the pros and cons based on the business problem we're looking to solve in order to make my decision to keep moving forward? If you can get graduates to the level where they can be showcasing that kind of thinking, then they automatically go up to the next level and they're probably going to find a lot more success landing roles. That's something I put a huge emphasis on with Data Science Infinity, those projects that people are really thinking about. Not just, hey, I did this stuff with Python. The stuff I did with Python is the small bit in the middle of the sandwich. Everything around that is important, from understanding the business problem. What metrics should we use to calculate success? How do we tie the technical solution to the business solution? And then at the other end, how do we get this implemented? How do we think about the impact, whether that's at a company level or customer level or an end user level? And that next level thinking, what would I do next time? What would I do if I had more time to work on this? That thinking where hiring managers see this person as not only, hey, they tick all the boxes, but man, they've got some growth potential and they're really a holistic thinker. They're thinking about projects from inception to conclusion and beyond. That's the most appealing thing you could get from a candidate.
Quick question, Andrew. Normally I'm very tight on the fact that if we've said it's 45 minutes, it'll be 45 minutes. Can we just ask a couple more questions?
Yeah, go for it.
For everyone else that has to go on to meetings, please do drop off. Normally I like to keep it on schedule, but there's 2 things that have popped up that I really want to get into. The first is from Deepak. I promised that we'd give him a chance to ask his question.
Deepak.
Hey, Colin, can you hear me?
There you go.
Good morning. The question I want to ask was, we see in companies, including ours, a central team trying to solve business problems, and business folks are scratching their heads saying, we don't really understand how business-specific challenges can be solved. And then there's also this problem of a long queue with the central data science team. How do you bridge the divide and democratize the data science, or I guess AI knowledge, across the company so that everybody's pulling the same direction?
Great question.
I think it's a big question. It's a big job trying to democratize data science across a company. I think it sort of comes back to that culture we were talking about earlier, making sure that data science isn't siloed on its own, or data engineering or data governance or any of these teams. They're all pieces of the data puzzle, and the data team is one piece of the business puzzle, and they all need to be connected. And that connection can only come culturally, and I think it has to come from the top down. I think there has to be a real emphasis and priority from the people at the top, like we were saying, Colin, to be data-driven and truth-driven, and to be realistic about what data science or data in general can do and what we can use other tools for. So as soon as you start embedding that culture, if you could aim for a 50-50 balance for your data scientists of commercial acumen, business thinking, and technical skills, unless you're trying to solve the most cutting edge problems in the world, which very few companies are, they're mostly doing the same sort of stuff. I think if you can get that balance right, that's going to slowly build up and snowball into people around the business who are maybe not technical. There are some very technical people within those teams, but sometimes they're not as technical as the data science team. If you can, let's boil it down to the chain which leads to value. The best skill a data scientist can have is somebody that can turn complexity, because often we're building complex things, into something intuitive. So if you can complexity of a mathematical formula or a machine learning algorithm into something intuitive that people can understand. So let's say it's somebody from marketing, they can understand what you're talking about and what the impact is. Understandable leads to them trusting you, right? They believe that when you say, when we put this onto the customers, this is what will happen from the business point of view. If you build trust, then you're going to start getting things put into action more. If you put things into action more, you're going to start getting more value. And if you start getting more value, that's when you get success at a business level. And as a data scientist, if you keep adding projects that are successful, you're going to get promoted to bigger and better things. But the thing that breaks that chain is at the very start of turning complex things into intuitive and understandable things. If you can somehow build a culture where every time a data science project is built, it has to be explained in a really intuitive, understandable way to the rest of the business, then I think not only will you get a lot more buy-in, you'll get a lot more trust, implementation, you get a lot more action, you get a lot more value, you get a lot more success. Yeah, it's that early link in the chain, which if you break that, you get nowhere.
All right, last question. I'll steal Ariella's because it's better than the one I had. Do you think executives should be forced to learn data science? And now I'm thinking about the CHRO, the head of HR, the head of marketing, head of sales, ExCo members, commercial directors. Do you think they should be forced to go on training in the same way they'll be forced to go on diversity training or compliance training or leadership training? But here we actually need to get them onto data science training because of the power of data science to enable their organizations. If they understand it, they might change the culture and put the systems and processes and people in place and think about it more, rather than just relying on technology teams to give them the answers.
Yes, I think so, but not to the same level that a data scientist should be trained, right? A person in a leadership team has their own things they need to focus on and be very good at. One of those things is to be good with data and to understand things from a data point of view, but I don't think they need to get right down to the details. That's where this culture I was just talking about is a responsibility of the data science team. The data science team should be able to go to the leadership team and explain exactly what they're doing in a way that other people will understand and in a way that ties the sort of data science metrics to the business metrics. And if you do that, then the leadership team doesn't necessarily need to go on a really intensive data science boot camp where they're understanding the nuances of neural networks. I think there's a framework of questions. This is a section from the course that I have, where you've got 5 questions for every technical project, 5 at the business level and 8 at the technical level. At the business level, what is the business goal for this project? Can the project be solved with data science, or does it not need data science? What's the minimum viable product look like? When does this need to be implemented? What ethics or compliant things do we need to consider? So that's at the business level. And then at the technical level, you've got more technical questions around the data itself and what it can tell us. If you have that framework across the board, it's like the business is a big circle. In the middle of the circle, you've got the data science team. They need to be connected. This framework of 13 questions is how you get everybody agreed on exactly how it's going to work. And it connects the data science and technical considerations and metrics to the key business ones, because that's often where it's lost. We're focused in data science on some accuracy measurement or F1 score in a machine learning project. That's not what the business cares about. They care about what does that mean for customer churn or whatever else it is. So how can we tie those things together and get a common language?
Thank you very much for joining us, everyone else. Thank you for joining the call as well. Been an absolute pleasure. Sorry, we've gone over just by a couple of minutes. I hope that's not inconvenienced anyone too much. I wish you a great remainder of the week and we'll see you all soon. Andrew, thanks again.
Thanks, Colin.